You're here because you want to understand the engine powering so much of the digital world cloud technology, but without getting lost in all the buzzwords.
Right.
You want the crucial insights, and you want them, well now, consider this your streamlined path to really getting the cloud.
Exactly. We've, sifted through the introductory stuff, the overviews, to really pinpoint the core ideas and, frankly, the most interesting parts of cloud computing.
Okay.
Our aim is to give you a solid grasp of what's happening, under the hood, and maybe spark a few of those aha moments where it all clicks.
And the resources we looked at, they seem designed for that. Clear explanations, relatable scenarios, analogies that actually make sense. So if you felt like the cloud is just some abstract thing, we're about to ground it for you.
Let's do it.
Okay, let's unpack this. When we talk about the cloud, what are we really talking about, like fundamentally?
Well, essentially, the cloud refers to a massive interconnected network of very powerful computers. And these are housed in specialized buildings called data centers.
Data centers, okay.
Yeah, think of a data center as a central hub, almost like a powerhouse that stores and processes just vast amounts of digital information.
So definitely not a fluffy white thing in the sky then.
No, definitely not.
Got it. The data center is the physical part.
Yeah.
And our access to all this is remote, yeah? I remember seeing an analogy, something about a magical locker.
Precisely. That's a good one.
Yeah.
Imagine a really secure off-site locker that holds all your digital files, runs your applications, everything.
Mm-hmm.
Instead of keeping everything right there on your laptop or your phone, you connect to this locker over the internet. You access your data, your software from any device, basically anywhere.
Okay.
It's a bit like the library idea, too. You don't need to own every single book, right? You just access what you need when you need it.
Right. You borrow it. Okay, so the data center is the physical warehouse. Now, cloud computing, that's the actual using of these remote resources for tasks?
Correct. Cloud computing is all about leveraging the power of those remote computers to do a huge range of things. And this is where we get into the three main service models. They each offer a different way to interact with all this infrastructure.
All right, let's dive into those models then. What's the first one?
So the first is SaaS, Software as a Service.
SaaS.
Think about the everyday apps you use online, Gmail, maybe Netflix, things like that.
Sure.
You access these programs through the internet, right? They aren't installed directly on your device. The analogy often used here is borrowing that book. You use the software, but you don't need to own or maintain the underlying stuff.
Right, I'm just borrowing access to those services.
Yeah.
Yeah, that makes sense. What's the next layer down?
Next up, we have PaaS, which is Platform as a Service.
That's
This is
similar.
more geared towards developers, people who want to build and deploy their own applications in the cloud.
Ah,
The analogy of a community kitchen fits quite well here, I think. You're given all the tools you need, operating systems, programming environments, but without the hassle of managing the servers or the network underneath. Google App Engine is a pretty common example.
so it's like a ready-made workshop for building and running your own software. I can see the appeal there. And the final piece.
That would be IS, Infrastructure as a Service.
Yes.
This is the most fundamental level. You're essentially renting the core computing resources, things like virtual servers, storage space, networks. The analogy here is like renting an empty building.
Right.
You get the basic structure, the space, and you have complete control over how you set it up and manage it. Amazon EC2 is probably the best known example of iOS.
So depending on what you need, just using an app, building one, or needing the basic building blocks, there's a cloud service model for it.
Yes.
PaaS, IS. Okay, that landscape is much clearer now.
Good.
Now, a term that comes up constantly is scalability. What does that actually look like in the cloud?
Scalability, yeah, it's key. It refers to the ability of these cloud systems to handle increased demand, usually by adding more resources. Think back to that restaurant analogy. If suddenly loads more customers arrive, they can bring in more chefs, more waiters to handle the rush.
Right.
And a really interesting part of this is auto-scaling.
Auto-scaling, that sounds pretty clever.
It is, yeah.
Mhm.
Auto-scaling means the cloud platform can automatically adjust the amount of resources being used based on the current demand. Like imagine a shop automatically opening more checkouts when the queue gets long.
Ah, okay.
The system just responds dynamically in real time. It offers incredible efficiency. You don't pay for what you don't need.
It's like having resources just appear exactly when you need them and disappear when you don't. Very neat. What about virtualization and instances? These always felt a bit abstract.
Right, they can seem that way. Virtualization is the core technology that lets a single physical server act like multiple independent virtual servers. The analogy of dividing a large classroom into smaller spaces with flexible walls works quite well.
Hmm.
Each of those virtual servers is called an instance. So think of it like one self-contained apartment within that larger physical building or one partitioned off section of the classroom. Technically, this is often done using software called hypervisors, but that's maybe getting a bit too deep.
Got it. So it's about squeezing more value out of the physical hardware. Makes sense. Now, with all these instances potentially running,
Yeah.
how do you manage the workload efficiently? I've heard the term load balancing.
Yeah, load balancing is crucial. It's basically the practice of distributing incoming requests or tasks evenly across multiple servers or instances.
Okay.
Picture it like a study group dividing up a big project so no single person gets totally swamped.
Right.
This stops any one server becoming a bottleneck and helps keep performance consistent for everyone.
Digital teamwork.
Ah,
Nice. Now, what happens when things inevitably go wrong? The sources mentioned redundancy and disaster recovery.
good question. Redundancy simply means having backup systems ready to go. It's about preventing single points of failure. The analogy of carrying an umbrella, even if rain isn't forecast, is pretty apt.
Just in case.
Exactly. Disaster recovery is a bit broader. It covers all the plans and procedures to get services and data back up and running after a major problem. Think of it like having a spare tire and knowing how to change it quickly if you get a flat.
Absolutely essential for reliability, I imagine. Now, let's talk about where these data centers actually are. I saw regions and availability zones mentioned.
Right. Regions are distinct geographic areas where cloud providers set up clusters of data centers. Think of it like a library system having main branches in different cities.
Okay, different cities.
Then within each region, there are usually multiple availability zones or AZs. These are separate data centers, but they're physically isolated from each other even though they're in the same general region.
Ah, so they're close but separate.
Exactly, like different supermarkets in different neighborhoods of the same city. This geographical separation really boosts resilience. If one zone has a problem, like a power outage, the others in the region can keep things running.
Clever. So if there's an issue in one spot, the others can pick up the slack. Smart. Okay, we've covered the computing power, the locations. What about storing all the actual data? Is that where object storage fits in?
Precisely. Object storage is a common way of storing data in the cloud. Instead of folders and files like on your computer, data is stored as individual self-contained units called objects.
Objects.
Yeah, each object gets a unique identifier like a serial number and metadata, which is data about the data. It's kind of like storing items in clearly labeled boxes rather than stuffing them into filing cabinets.
Okay, labeled boxes in a massive digital warehouse. Got it.
It offers great scalability and flexibility, especially for huge amounts of unstructured data like photos or videos.
Right. Now, how does all this information actually get to us? I saw terms like traffic and bandwidth.
Good point. Traffic basically refers to the amount of data moving across the network at any given time. Think of it like the number of cars on a road.
Okay.
Bandwidth is the capacity of that network connection, how much data can move at once. So that's like the number of lanes on the highway. More lanes, more cars can move at the same time.
More bandwidth, more data.
Exactly. And to make this faster and smoother, especially for content like videos or images, we have CDNs, content delivery networks.
CDN, that sounds like it speeds things up.
It does, significantly. A CDN is a network of servers spread out geographically, all around the world, actually. They store copies or caches of popular content much closer to where the end users are. Think of it like having mini libraries scattered all over the city, so you don't always have to travel to the main central library to get the most popular books.
Ah, go ahead.
This reduces the distance the data has to travel, which cuts down latency, the delay, and makes things like video streaming much smoother.
That totally explains why videos start playing almost instantly sometimes. Okay, let's step back a bit and look at the bigger picture. We mentioned on-premises setups earlier. How does that really compare to using the cloud?
Right. On-premises or on-prem, as you sometimes hear, means having your IT infrastructure, so your servers, storage, networking gear, all physically located within your own building or office.
Like cooking at home?
Exactly like cooking at home. You own the kitchen, the ingredients, everything. Cloud computing, as we've discussed, is more like ordering takeout.
Okay.
You're accessing and using resources that are owned and managed by someone else off-site. And cloud migration is simply the process of moving from that on-prem setup to using cloud services.
Like deciding to stop tending your own garden and joining a community garden project instead.
Yeah, that's a pretty good analogy. It's a fundamental shift in how you manage and pay for your IT resources.
Okay, now there aren't just one type of cloud, right? I saw distinctions between private, public, and hybrid clouds. What's the difference there?
Correct. A public cloud is like a public park. The infrastructure and services are provided by a third party like Amazon, Google, or Microsoft, and they're available to anyone over the internet, usually on a pay-as-you-go basis.
Anyone can use it.
Pretty much. A private cloud, on the other hand, is like a private swimming pool. The cloud infrastructure is dedicated solely to one organization. They might manage it themselves or have a third party manage it for them, but it's theirs.
More control, more privacy, maybe?
Generally, yes. And then a hybrid cloud is, well, a mix of both.
That's the despicable of worlds.
Potentially. Organizations might use a public cloud for less sensitive tasks, like web hosting or development, but keep their critical data or core applications in a private cloud for more control or security. It's like growing some of your own vegetables, but still buying others from the supermarket.
It's about finding the right mix for your needs, access and control. Makes sense. Now, a huge topic with anything online is, of course, security. What are some key security ideas in the cloud world?
Absolutely critical. Security is paramount. A firewall is a fundamental piece. It acts like a gatekeeper, controlling network traffic coming in and going out, blocking unauthorized access. Think of it like a bouncer at a club checking IDs.
Okay, controlling access.
Then there's IAM identity and access management. This is all about controlling who can access what resources within the cloud. It's like having different keys for different rooms in a building, ensuring people only get into the areas they're supposed to.
Right, permissions.
Exactly. And a VPN, a virtual private network, creates a secure, encrypted connection over the public internet. It's like having your own private, secure tunnel for your data to travel through, keeping it safe from eavesdroppers.
Those analogies really help visualize how these security layers work. Okay, wow, we're covering a lot. What about some of the newer, maybe more advanced concepts? I've heard about serverless computing and edge computing.
Yeah, those are really interesting developments. Serverless computing is a bit of a misnomer because there are still servers involved.
Ah, okay.
But the point is, the developer doesn't have to manage them at all. You just write and deploy your code, and the cloud provider automatically handles all the underlying infrastructure provisioning, scaling, and management.
So you don't worry about the servers.
Exactly. Think of it like using a taxi or ride-sharing service. You just pay for the ride when you need it. You don't own the car, worry about insurance, maintenance, or finding parking.
Very convenient. And edge computing.
Edge computing is about moving computation away from centralized data centers and closer to the source of the data, the edge of the network.
Closer to where things are happening.
Precisely. Imagine sensors on factory equipment or smart devices in a city. Instead of sending all the raw data back to the cloud for processing, some analysis happens right there, locally, on or near the device. This reduces latency and bandwidth use, which is crucial for real-time applications like autonomous vehicles or industrial automation.
Like having a mini brain closer to the action. Makes sense for speed. What about API and cloud native? Those sound like terms you hear developers use a lot.
They are common, yeah. An API application programming interface is basically a set of rules and protocols that lets different software applications talk to each other and exchange data.
Like a translator.
Sort of, or maybe more like a waiter in a restaurant. The waiter, the API, takes your order, your request, communicates it to the kitchen, another system, and brings back your food, the response.
Yeah.
It defines how requests should be made and what responses to expect.
Okay, the rules for communication and cloud native.
Cloud native refers to applications that are specifically designed and built from the ground up to take full advantage of cloud computing models.
Built for the cloud.
Exactly. They're designed to be scalable, resilient, and flexible, using things like containers and microservices, which we haven't really dived into, but they leverage the cloud architecture effectively. It's like designing a boat specifically for water rather than trying to adapt a car to float.
Got it. Optimized for the environment. And you mentioned containers. I've definitely heard that term.
Right. Containers are a way to package up software code along with all its dependencies, libraries, configuration files, everything it needs to run into a single standardized unit.
Like a self-contained package.
Exactly. Think of them like standardized shipping containers for software. They make it easy to move applications between different environments from a developer's laptop to testing to production across different clouds reliably and consistently.
Very efficient for deploying things, I bet.
Yeah.
Okay, we've hit on quite a few terms now. Maybe we can quickly touch on a few more I saw. Fault tolerance, latency, bare metal server, multi-tenancy, backup, and SLA. Just the gist.
Sure, quick definitions. Fault tolerance is a system's ability to keep operating, maybe at a reduced level, even if some component fails, like a car that can still drive even with one headlight out.
Okay, keep going.
Latency is the delay, the time it takes for data to travel from point A to point B, like the lag you sometimes get on a video call or mailing a letter versus sending an email.
The delay. Got it.
A bare metal server is a physical server that's dedicated entirely to one customer. No virtualization layer, no sharing, like renting an entire house instead of just an apartment.
All yours.
Multi-tenancy is the opposite, really. It's where multiple customers share the same underlying infrastructure, but their data and configurations are kept separate and secure. Like different apartments in the same building sharing the same foundation and roof.
Sharing resources safely.
Backup is simple, just keeping a copy of your data somewhere safe in case the original is lost or damaged, like making photocopies of important documents.
Essential.
And finally, an SLA, service level agreement, is basically a contract between a cloud provider and a customer that defines the expected level of service. Things like uptime guarantees, performance benchmarks, support response times, like a warranty or a service guarantee.
The promise is, okay, wow, we really have covered a lot of ground. But honestly, those analogies have helped make some pretty complex ideas feel much more concrete.
Good, that was the goal.
So now that we have a clearer picture of the mechanics, how does all this cloud tech actually, impact our everyday lives and maybe the broader world?
Oh, it's huge. These technologies, they underpin so much of what we do online every single day.
Like what?
Well, streaming video services, social media platforms, online banking, shopping online, even just storing your photos, almost all of that relies heavily on cloud infrastructure running in the background.
Right, it's invisible mostly.
Exactly. And for businesses, the benefits are massive.
Yeah.
We touched on cost effectiveness, not having to buy and maintain loads of expensive hardware upfront is a big one, but also things like agility, being able to scale resources up or down quickly, flexibility to adapt, supporting remote workforces much more easily, and as we mentioned, much better disaster recovery options.
Yeah, you can see why businesses have embraced it.
Absolutely. And think beyond business, too. Scientific research, for instance. Cloud computing lets researchers analyze absolutely enormous data sets. Genomics, climate modeling, particle physics, accelerating discoveries in ways that just weren't possible before.
That's incredible.
Yeah.
So it's easy to just take it for granted how much we rely on this stuff. And it's not just about convenience, is it?
Not at all. It's really a key enabler for innovation across so many areas. It's powering smart city projects, optimizing traffic flow, managing energy grids more efficiently. In education, you've got online learning platforms, wider access to resources. The core idea really is democratizing access to serious computing power, making it available on demand, almost like a utility like electricity or water.
So yeah, this isn't just some tech trend. It feels much more like a fundamental shift in how we use technology, how we solve problems.
Precisely. Cloud technology provides this accessible, scalable computing power, and it's fundamentally reshaping our entire digital landscape.
So for you, our listener, as you go about your day-to-day, maybe think about this. How many of the things you do online, sending a message, watching a quick video, saving a file, how many rely on that magical locker we talked about? And maybe ponder how these cloud capabilities might keep evolving. What new possibilities could they unlock in the future? It's a pretty fascinating thought to leave you with.
Indeed it is. And if any specific part of this sparked your interest, maybe serverless or edge computing or security, we definitely encourage you to explore it further. The world of cloud computing is vast and it's constantly changing. There's always more to learn.